Okay. So the name of the question is bag of tokens, and in the question we will be given array of tokens that will be consisting of some digits from 0 to 1000. 0 to 1000 will be the length of the tokens, and the token could be vary from 0 to 10 to the power 4. So token of I, and as a input we will be given a list of token. Let's say this 100, 200, 300, 400, like that, and a integer power that will denote the initial power that is given to us. And in the problem statement it is given uh, if the current power is at least token I. So for this example, as 100 is less than 200 and that 200 is equal to 200, so we can perform some operation in the token. We can play the ith token, uh, we can play with the ith token and move it to face up. And what does face up mean? Face up means that we will decrease our power by that token. So if we have chosen 200 for example, so our power would be 200 minus 200, and for doing that operation we will increase our score by 1. So score is not given there, we have to initialize it as 0, and after every phase of operation we need to increase our score by 1. So that is the problem. And one more thing, if we need to perform face down operation we can do that, but for that we need at least score as 1. So if our score is 1 and power could be anything, let's say power is 0, as we have decreased our power by 200, so we can do something like we can add this 30 to our power. So power would be 30 and our score will decrease by 1 for doing face down operation. So score will be 1 minus 1, it will again be 0. So while performing this operation we need to find the maximum score that we can obtain, and we need to return that as our answer. So yeah, and one more thing, for each token we can replace we can perform face up or face down operation just one time. So if we decrease that, if we do face up operation with that, we can't do face down operation with that again. So this is uh, pretty much it. So I think you guys must have come to the solution that for taking for making a face down operation, which is taking the power, we need to take the maximum from the tokens. So we can do that greedily. So if we take the power as 400, if we take the power as initial as 200, and if we let's say decrease the power by 100, then we will have our power as 100. And after that if we add 400 to our power, so our power will be 500. Just by doing this operation we'll always get the maximum and add that to our power, and in case of decreasing we will decrease the minimum from our power. So just by doing greedily we can get to the maximum score that we can obtain. So for doing that, the optimal way could be to sort the array and traverse through the array from by using two pointer. So let's say there are 100, 200, 300, 400, 500, and initially let's say power is 200, and we need to initialize the score as 0. So if we do if we perform operation with the least the smallest integer that is present in the token, and let's say p1 is pointing to the first element, which is the least element, and p2 is pointing to the last element, which is the greatest among all. So if we need to if we want to perform our power operation with 100, we can do that because that is less than the power. So we can decrease power by 100, so power will be 200 minus 100, that would be 100, and we can increase our score by 1, so our score will be 1, and we will move our pointer to p2 because we can't perform more operation on 100, right? So we will do that, and p2 is still there. After 100 we can see that power is less than the element that is pointed by p2, so we can't do this operation more. So for that we need to gain more power, and for doing that we can add that to our power, and since our score is more than 0 we can perform that operation. So we'll add that to our power 500, so our power will be 600, and our score will be 1 minus 1, which is 0, and our p2 will move to 400, and it will point to 400 as we can't do more operation on 500. After that we can see that we can perform operation on 200, so we'll do that, and we'll decrease our power by 200, and our power will be 400, and our score will increase by 1, so our score will be 1, and p1 will point to 300. So our power is still more than the number that is pointed by p1, so we can do one more operation and remove that from the power. So if we subtract 300, that would be 100, and our score will be increased by 1, so our score will be 2, and p1 will not point to this anymore, so p1 will point to this. After that we can't do p1 operation, we can't subtract 400 from 100, so yeah, we'll just decrease that score by 1 and add that to our power. So our power will be 500, and since p2 will now move to there, and if at any point p2 is the element pointed by p2 at that index, if that is on the left side of the index of p1, then we can stop like this. Here p1 is pointing to 0 1 2 3 4, 3, p1 is pointing to index 3 and p2 is pointing to index 2, so that is not valid, so we will stop our loop or whatever we use, and yeah, we will get the answer till now whatever the maximum score we can obtain. So the score would not be 1, the score would be 2. Why? Because we need to find the maximum score we can obtain. So if we have stopped the process here, we would have got 2 as our answer. So we can use a maximum score variable to store the maximum score at each point. Okay, so now we can do that. Let's move to the code.